This conference will now be recorded.
Hey guys, a very good morning. Can you hear me, everyone?
Hi, Suresh. Yep.
Yes, I can.
Perfect. Cool. A very good morning and good evening to everyone who have joined this session. Um, since this is the first session, we started it a bit delayed, guys, because we just want everyone to join. Okay. I think probably we can get started, and I see some of you are part of my um, demo, and a few others are joining today. Okay. So let me tell you agenda of today's session, and then probably we'll get started. First thing is all about introduction of mine and introduction of yours. Okay, and then I'll be introducing this course to you. Introduction to our course. Okay, and then I'll try to introduce what is big data to you. Okay, so could be some repetition on what you have already heard in demo. If you have joined demo, if you aren't part of the demo, it would be completely new. Okay, and I'm gonna walk you through the course plan as well. You will get a good understanding on what we are going to discuss for next few weeks. Okay, so let's get started. Let me introduce myself. I'm Suresh, guys. I'm going to be your trainer for next couple of months. I'm a Spark developer right now, where I'm working on Azure platform. Okay, basically I'm developing Spark applications on Azure platform. I'm having close to 7.5 years of experience, out of which I have been training folks on big data and related technologies from past 5.5 years. Okay, I started my training career in around 2015, and the journey still continues. So when I started, I used to teach like Hadoop related technologies, and then I have seen all the transformation from Hadoop till Spark, from on-premise cluster till cloud. So I'm gonna walk you through all this transformation as well, so you'll get some good knowledge on these technologies, and you can apply it in your jobs, or if you are looking for a job change. Yes, this course will help you. And last 10-15 minutes I'm gonna spend on your questions and answers. Okay, so please use chat window, guys, for most of the time until and unless it is really necessary. Please don't unmute yourself in the interest of recording. This session is being recorded. This session is being recorded, so I don't want you to unmute yourself and talk. that would disturb the recording. So let's try to interact as much as we can via chat. And like I said, if it is necessary, definitely you can unmute yourself and you can talk. I'm not stopping you from doing that, but let's try to avoid that as much as we can. Okay. Now I would want you to introduce yourself either by chat window or however you would like to interact. Okay. So to avoid to avoid overlap, you can probably use chat window to introduce yourself. I could see your names. I just want your experience. I just want your what you call. I just want your experience and how many years of experience you have, the current technology you are working on, and your expectations out of this course. These are the three things I would like to see in your chat window. Probably you can introduce yourself to everyone in the session so that everyone will get to know. I'm still waiting, guys. Seed MS in computer science, 2 years of experience in MSBI. Okay, Microsoft Business Intelligence. Pawan have total 10 years of experience on Oracle ERP. Years experience currently working in ML field. Okay, PL SQL developer. Great. 8+ years of experience in PL SQL developer. Good. So we have a mixed bag of students. Like we have students starting from freshers. We have students with 2 years experience, 3 year experience, and till 10 years of experience. That's good to have. Like I would always refer these sessions as knowledge sharing sessions rather than training sessions, because here we actually share our knowledge. Okay, as I always say, it's always bi-directional, right? So did we cover everyone? Okay, for a couple of folks who just joined now, we are actually introducing ourselves. So if you would like to introduce yourself, I just want to hear from you, your years of experience, the current technology you're working on, and your expectation out of this course. You can probably use the chat window. Okay, let's get started, guys. Let me introduce this course to you. Okay, so the title of this course is Spark on Azure. It is named this way for a purpose. Okay, so most of the organizations today have moved from on-premise environments to cloud environments. Let me explain. So the scenario in 2014 2015 was completely different. big data is not everyone's cup of tea. So the only big consulting firms like TCS, Infosys, Cognizant, etc., companies like this used to have their cluster setup. So a cluster is nothing but a group of computers. You all might already know that Hadoop is a distributed computing environment, or the big data related technologies are a distributed computing environment. Okay, so what do I mean by distributed computing environment? Whatever data you want to process, or whatever data you want to store, it is stored in a distributed fashion on multiple computers, and it is also processed on multiple computers parallelly, right? Anyway, I will be walking you through how it is done, but at a high level, this is what happens for any Hadoop related technology, be it Hive, be it MapReduce, be it Spark. Your data would be stored on multiple machines, and your data would be processed on multiple machines. Okay, so companies like TCS, Infosys, any big consulting firm, okay, used to have their cluster setup on premise. When I say on premise, in their own company's premise. Okay, and they used to have a separate admin team to manage the cluster, because maintaining such a huge cluster would involve a dedicated administration team. Okay, so when I say huge cluster, you might ask me, boss, you said processing would be done on multiple computers. Okay, so how many of such computers are required? Maybe depends. The clusters I have worked on has a minimum of 300 computers. I have seen a cluster with 300 computers in TCS, and then when I have moved on to my next company, there people were using a cluster with 656 nodes. And then I moved on to another company. There I have seen a cluster with 450 computers. Okay, currently we are working on cloud technologies. I mean, developing the same big data solutions on a cloud environment. Okay, so yes, companies like this used to maintain on on-premise clusters, but now the trend has been changed from on-premise clusters to cloud. Be it clients or be it businesses, even the same consulting firms are now suggesting clients to go with cloud. Even clients have become more intelligent. Even they wanted to stick to cloud. There are a lot of problems with on-premise clusters. When I talk about on-premise cluster problems, for client, he will have to bear the administration cost as well, in addition to maintenance. Sorry, in addition to development cost. Okay, because a dedicated admin team is working on, and then it's going to be your headache to maintain the infrastructure as well. And then you have to take care of a lot of challenges, like you have to take care of scalability. So the meaning of scalability is the storage requirements or processing requirements of your infrastructure should adjust according to the data growth. Maybe today your data is 5 TB, or your data is 5 petabyte. Okay, maybe tomorrow if it becomes 10 petabyte, you will have to adjust your infrastructure accordingly. Okay, so and there are just a few problems to mention, but there are a lot more problems than what we have discussed. So these are all the reasons which are prompting clients as well as the consulting businesses to move on to cloud rather than sticking to on-premise clusters, because they wouldn't be having any overhead on administration. I still remember in 2014 and 2015, the demand for Hadoop administrators is too good. Okay, so who are these Hadoop administrators? They are coming from Linux background. They are nothing but Linux administrators. So companies used to recruit them and then train them, maybe train them for 2 months, 3 months, and then deploy them into a project. They get 1 year, 1.5 year experience, and they get 200% hike, jump to other company. I have seen a lot of such resources. Okay, so that's how it used to be. So you cannot even rely on a team, because the demand for a Hadoop administrator is so huge at that point in time. And also the most of the healthcare companies, most of the insurance companies, most of the banking companies, you name any domain, they all wanted to invest a lot into big data projects, just to see what big data solutions are capable of. what advantage their businesses can get. Okay, so that's how the scenario used to be. But now, like I said, people have realized all the problems with these on-premise clusters, and now they started moving on to cloud, right? When I talk about cloud, we have three big players in the market. One is Amazon's AWS, and then Microsoft's Azure, and Google's GCP, Google Cloud Platform. AWS, Amazon Web Services, Azure, Microsoft Azure, and then Google's Cloud Platform. These are the three big players in the market right now for cloud-based solutions. Okay, so what is a cloud? Before we jump on to these cloud services, let's talk about cloud. What is a cloud? To put it in a layman terminology, a cloud is nothing but someone else's computers, someone else's computer. Okay, maybe I don't want to buy a laptop. We'll take a small example. Today I wanted to run some complex data science algorithms. Maybe I wanted to run some complex data processing steps. Okay, the current infrastructure of mine is not sufficient. Maybe I'm using a laptop with i5 processor, and I'm using a RAM 8 GB, RAM capacity of 8 GB. Okay, and also my storage space is 1 TB. So definitely, I'm sorry, I have a requirement where I need to process 2 TB of data. So I will not be able to store the 2 TB of my data, 2 TB of data in my laptop, and then definitely the kind of processor and RAM I have, I'll not be able to process the data as well. Now, do I need to buy a new laptop which would be capable enough to do this? Okay, I will buy a new laptop. Even I'm fine with that. What if tomorrow I have to process 3 TB of data or maybe 4 TB of data? Do I need to keep on purchasing new laptops every time my requirement changes? Is that a good approach? Definitely no. Definitely no. So what I would do is I would rent a cloud infrastructure. When I talk about cloud infrastructure, maybe Sid is having a cloud infrastructure. When I say cloud infrastructure, let's say maybe he have a workstation at his home. He have a workstation at his home. Maybe let's say his workstation capacity is 64 cores, 64 cores, and he have close to 256 GB of RAM, 256 GB RAM, and then he have storage space of 10 petabytes. Let's say these are his workstation configurations, and maybe he will not be using all these configurations, and maybe he want to make some money out of these configurations. Now what he would do is he would create a network based environment where others can interact with his system and get their tasks done. Okay, now what I would do is I would call Sid and tell him my requirement. Boss, today I would need 8 cores because my i4 is a i5 is a quad core processor. So 4 cores is not sufficient for me to process my data. I want maybe 8 cores, and then 8 GB of my laptop is not sufficient. I would need 32 GB RAM, and I would want maybe 5 TB because today I have 2 TB of data. In a futuristic thought process, I would take maybe 5 TB. This is what I would ask him. I would request him. Now what Sid will do is he would create a virtual machine. He would create a virtual machine with these configurations, and he will give me access to this virtual machine via network. Okay, and in order to interact with this virtual machine, he would provide me with a web portal. Okay, so all I just need to do is I have to log into that web portal and then access his virtual machine, give proper credentials and access his virtual machine. Okay, maybe tomorrow if I want 2 more cores, all I just need to do is request him and he should be able to do it. Maybe I want to add more cores, all I just need to do is request. Okay, sometimes he can also come up with a strategies like boss, you don't even need to purchase 5 TB of data. I have written an algorithm in such a way that storage would be allocated on your requirement basis. Maybe you are uploading 2 TB of data, you will automatically get 2 TB of data. Maybe you have deleted 1 TB of data, your storage would automatically get reduced to 10 TB of, 1 TB of data. Maybe you upload 10 TB, dynamically 10 TB data would be allocated to your account. Okay, this is what we call as elastic cloud. This is what we call as elastic cloud. So based on your requirement, the resources that is allocated to your account would be elastic in nature. It would increase as and when required, and it would decrease when it is not required. Okay, so adopting to this approach would save a lot of money to the organizations. Okay, because they are requesting all the infrastructure on demand based on their requirement, first thing. And second thing, they don't really need an administration team on their end, because everything is being handled by SID. SID is responsible for making it available 24/7, 365 days. Okay, so basically you both will be signing a SOW as well, statement of work, in which SID would be specifying that maybe some hours of downtime is allowed, maybe some amount of downtime is allowed for entire year, for an entire year. Okay, so I would say those number of hours would be hardly 1 or 2, not more than that. I'm working on Azure, guys. I have been working on Azure for past couple of years, and I hardly see downtime for around half an hour, not more than that. Okay, because they will have all the backup resources as well. So what Sid will do is he will have another backup workstation with the similar capabilities, and will have everything up and running on that workstation as well. If something went wrong with this workstation, he would be providing access to the other workstation, so that remote users work, users like me wouldn't, my work wouldn't get interrupted. Okay, so this is the simple concept of cloud. Now, the big players like Amazon, Microsoft, and Google have wanted to make money out of the same concept, and they have come up with their own services. We call it as AWS, provided by Amazon, Amazon Web Services, and then Microsoft cloud product is Azure, and Google's cloud product is GCP. Okay, so GCP is a new entrant into this market. It started making its mark only from 2017, but I'm still amazed by the way it was able to capture good market. Now, it has managed to capture almost 15 to 20% of the market right now. Okay, and talking about AWS, AWS has always the advantage of being the first one. Okay, so earlier in 2013, 2012, 2014, when you talk about cloud, you talk about AWS, as simple as that. Okay, it's the first entrant into the market, and it will always have that edge. But talking about Microsoft, when Satya Nadella has taken it over, there is no looking back, because he have invested a lot of amount on cloud, developing cloud solutions on Azure. And because you already have an established player in the market, in order to compete with that player, you have to have your own ways of pushing your product into the market. So one innovative strategy he has come up with is dividing the compute and storage. Okay, so that's one thing which grabbed a lot of eyeballs on Azure. And after that, he introduced many tools, many simple tools, which would provide integrations between all the Microsoft stack. Integration with Outlook, integration with SharePoint, integration with Teams, integration with a lot of other tools which Microsoft offers for their users. Okay, and most of the users in the current industry are of Microsoft, people who use Microsoft Outlook, Microsoft Teams, Microsoft SharePoints, okay, and then MS Office, right? Most of the organizations in the current industry are using Microsoft products. So that has become a huge advantage, and Azure was able to easily catch up the market of AWS. Okay. Now, if you ask me what are the major players in the market, I would say both Azure and AWS. They both have the equal demand, and they both have the equal opportunities as well, job opportunities. Okay. So we are going to learn Azure in our course. I mean, I won't be teaching you what Azure is, but I would be teaching you basics of Azure, and I'll show you how to deploy your products on Azure. Especially, I would be showing you ADLS and Azure Databricks, and also Data Factory, Azure Data Factory in our course. And we will deep dive into these services. Like we will get to understand what ADLS is exactly, and then we'll get to understand how we use Databricks to process data, and we'll get to understand how we ingest data from different sources using ADF, Azure Data Factory. Okay, so let me try to set up the right expectations. I'm not gonna walk you through what Azure is, because this is not an Azure developer course, but we will be using Azure as a cloud platform to run our services, which would help us to develop big data solutions, as simple as that. Okay, but we will talk a lot of nuances of cloud. Like, what are the different types of clouds we have, what are the different cloud services we have. Okay, and I'll show you how to set up this account. Okay, and then like I said, I would show you how to deploy any component or any services on cloud, that I'm going to show you. Okay, and now let's talk about Spark. And now let's talk about Spark. So when big data was started, when big data related technologies were introduced into the market, it used to be only MapReduce. It used to be only MapReduce. So you want to work on big data, you have to learn MapReduce, which is like a hell. Okay. Let me tell you what, any guy who want to work on data will have couple of skills there. One is SQL skills, and if you are a data scientist, maybe you would be little familiar with programming languages like R and Python, because there are only three roles who work on data. One is data engineer, second one is data scientist, and third one is data analyst. I repeat, data engineer, data scientist, and data analyst. Okay, if you are not part of my demo, I would recommend you to go through the YouTube recording, upload it. Please get back to me if you want link of that video. Okay, so there I have clearly explained the difference between these roles: data engineer, data scientist, and data analyst. Okay, so these are the three guys who work on data, right? And data engineer will have SQL as a skill set, SQL as his primary skill set. Data scientist would know some programming language. He is not as proficient as a typical application developer, but he will have some good hands-on with R and Python. There are a couple of programming languages which is widely used to develop data science applications, R and Python. Okay, and then data analyst, this guy would be having some tools as skill set, data visualization tools as a skill set. So the most widely used data science tools, data visualization tools are Tableau, data visualization, or people call it as BI, business intelligence, or people also call it as reporting. Okay, or BI reporting, sometimes people refer it to as BI reporting, business intelligence reporting. And then we have Power BI, and MicroStrategy, and then Google's Visual Studio. There are a lot of such tools. I don't want to get in depth, but these are the most widely used tools. Okay, I would ignore Visual Studio as well. Most widely used tools are Tableau, Power BI, and MicroStrategy. But in order to develop any solution on a big data platform, you will have to know Java. You will have to know Java, That too, basic Java is not enough to develop MapReduce application. You will have to know the complete Java. Okay, so that is when people started bringing up application developers, Java application developers to Hadoop environment to develop solutions. Okay, and these folks always have that data knowledge gap. Maybe like I'm a typical data engineer. If someone comes with a data set and if he asks me to move that data set to my data lake by doing XYZ transformations, XYZ transformations. Okay, so being a data engineer, I would understand what are those XYZ transformations and I should be able to do it. But if you ask a if you ask an application developer to do XYZ transformations, he wouldn't know what are those XYZ transformations. So there was a huge knowledge gap there. So for doing one job, there used to be a couple of resources. One guy is called as Hadoop developer and other guy is called as Hadoop analyst. This Hadoop analyst is typically a data engineering background guy, and this Hadoop developer is typically a Java background guy. Okay, that's how people used to work on MapReduce. And then, a new tool called Hive has been introduced. A new tool called Hive has been introduced. Hive supports SQL. Hive supports SQL. People call it as the HQL, Hive query language. It exactly looks like SQL. It exactly looks like SQL, but there are few differences on how it operates. Then it has provided some luxury to data engineers to work on big data platform without really having to depend on so-called application developers. Okay, so you might have heard Hadoop is a failure, or Hadoop haven't succeeded as much as it is anticipated to be. Okay, or maybe you might have heard this term as well, Hadoop is dying. So most of the applications, yes, I do agree, most of the applications that are developed using MapReduce and Hive were stopped at POC stages itself. POC, the meaning of POC is proof of concept. So generally, before we jump onto a full-time project, we kind of do a sample project, what we refer to as POC, proof of concept. Okay, so most of the projects were stopped in POC stages itself, but companies were able to make huge profits with that POCs itself. Okay, because that's how the demand for big data used to be, or Hadoop framework used to be. Okay, so in order to bridge these gaps and to make it a better platform, people have come up with something called as Spark. But when Spark was initially introduced, there are a lot of hiccups to onboard people onto this environment, because Spark uses completely new language called Scala, which is a functional approach, which is a functional programming language approach. People really found it difficult, even for the folks who already have some good hands-on with MapReduce. They initially found it very difficult to get there. The reason being, not much documentation is available, and every small problem or implementation of every small problem on Spark platform was a challenge. Okay, I still remember it was in 2015 this transformation started. Okay, so I started working on Spark even when it is not matured, from version 0.8. Okay, so usually we consider any tool with version 1 or later as the latest one, sorry, stable one. Okay, so we started working on Spark from version 0.8. So at that time it was like hell. So no documentation is available, you cannot find any answers in Google. It was like reading documentation and implementation. You're stuck somewhere, you are stuck. Okay, so once in every month, these Cloudera folks, we were using Cloudera cluster back then. Okay, Cloudera folks used to visit our organization and have discussion with the developers who are working on Spark. So all the struggle started from there. And if you see the environment, what we currently have, Databricks or any other environment, the problems, uh, the current luxury, whatever you are seeing, has been implemented over the years by taking feedback from all the challenges that are being faced by developers while implementing solutions. So Spark has started gaining prominence from version 1.5. The reason being, they have introduced a couple of technologies there. I mean, couple of programming languages support. One is R and second one is Python. Okay, so introducing Python onto Spark environment has made this revelation. Okay, so everything, I mean, the way people used to look at Spark has changed. Now, all the data engineers were able to onboard onto Spark because Spark supports SQL and you can develop Spark solutions pretty simple approaches. And next thing, uh, Python, I mean, Databricks have supported Python, and that led organizations to onboard data scientists. Even data scientists have accepted Databricks with an open heart. Okay, the reason being, they need to make minor adjustments to their Python code, just minor adjustments. So they have the same pandas way of implementing solutions. They have same numpy ways of implementing solutions. They have all the libraries available which runs in a distributed fashion. So all they just need to do is minor adjustments to their existing codes. So even data scientists have accepted the Databricks Spark with open hands. Okay, and then they have built a strong support for streaming data as well. Earlier, dealing with the streaming data was a challenge. Okay, and what exactly is this Databricks? People have been talking a lot about Databricks. What exactly is this Databricks? So basically, Spark is an open source tool, guys. When I say Spark is an open source tool, you can use it for free of cost. You don't really need to spend any money from your pocket to use Spark. Okay, so the only amount you'll have to spend is on setting up your infrastructure if you are working on an on-premise cluster, right? So what happened was the inventors of Spark. So Spark was the result of a research project from UC Berkeley University. Okay, so the folks who have invented this Spark, once they come out of the college or university, they started their own organization called Databricks. They started their own organization called Databricks. Okay, with only one single agenda, making Spark easily available for development. Okay, so you come from a SQL background, you should be able to work on Spark. You coming from a Python background, you should be able to work on Spark. You coming from non-technical background, with minimum effort, you should be able to work on Spark. Maybe by knowing some basic templates, basic Python and basic SQL, you should be able to work on Spark. And I still remember while I'm using on-premise clusters and the distributions like Cloudera or Hortonworks, deploying a Spark job is like a hell. We used to ruin our day or a couple of days just to deploy it and go through that phase of running for the first time. Okay, maybe for the second time it's okay because we would have solved a lot of problems that we have faced in the first go. But so in the second go it would be little easier. But now it's a matter of 10-15 minutes, not more than that. I'm not exaggerating it. You'll see it. Okay, so that's the beauty of Databricks. And this Databricks is financially backed by Microsoft. Like I said, the strategies of Satya Nadella on improving cloud services was too good. There is no match for the strategies they have come up with. Okay, so they backed Azure. I mean, they backed the Databricks folks like anything. And then these Databricks folks have come up with an environment where developers can develop Spark applications pretty easily. So if you guys are familiar with Python, if you guys are familiar with Jupyter Notebook, your Databricks notebook would look exactly similar. Okay, and then you can write line by line code and you can check output at every single line. Okay, I mean, you will be seeing all those things in the coming sessions, but yes, that's how easier I mean, it's now that easier to develop applications using the Spark framework. All credit to Databricks folks. Okay, and like I said, they are heavily backed by Microsoft. The first cloud platform to launch Databricks was Azure, followed by AWS, and now Databricks is available in GCP as well. Okay, if you are comfortable with AWS, if you are comfortable with GCP, please feel free. you may use the same Databricks platform on those two clouds as well, because Databricks is a platform as a service. Databricks is being offered as platform as a service. Okay, so the Databricks is available in AWS. Databricks is also available in GCP. Okay, so whatever cloud you are comfortable with, please go ahead and use it. In our course, I'm gonna teach you Databricks on Azure. Okay, and you might ask me, boss, you told us that Spark can be implemented using Scala, using Java, using Python, using R. What programming language are we going to use in our course? I'm going to use Python as a programming language to develop Spark applications. People refer it to as PySpark. Okay, so this is how our course is planned, guys. Okay, so week 1 and 2, I will be introducing you to big data. Introduction to big data. Probably tomorrow I will talk about big data, and I'll be talking about a lot of interesting applications, what we do using big data. Okay, and then um, we will be talking about Python. I would say core Python, right? So in these Python sessions, I would be teaching you all the Python, at least the minimum Python, which would help you to start developing Spark applications. Because if I teach Python as a course, entire 2 months would be sufficient to learning Python itself. Okay, so I don't get into object-oriented concepts, but I'll be teaching you, how to write Python code. I would be teaching you important concepts like conditions, loops, and control structures. Then I'm gonna walk you through collections framework. Okay, I'll be walking you through everything that is required for you to understand this course. Okay, so this is what we're gonna do in first couple of weeks, and then week 3 is all about setting up your Azure account. Okay, so when I say setting up Azure account, this is when you will get a good understanding on the cloud environment, different services we have, different types of clouds we have. Okay, and what are the different set of tools a cloud has to offer, and then we will try to do an comparison between the clouds that are available, AWS versus Azure versus um, GCP. Okay, and I will show you how to deploy services on Azure. So basically this V3 is all about cloud. Okay, and we will be deploying all the services we need to learn Spark on Azure during week 3. So Azure would be offering you a free subscription of $200 for a month. Okay, so you might ask me, boss, what after that month? I have alternates. I'll be talking about those alternates at a later point in time. Okay, so Databricks offers their environment as a community edition, which would help you to develop applications. There are minor adjustments which you'll have to make to your code. Probably while I'm walking you through that, I would be showing you those changes as well. So if you don't want to spend some money from your pocket, which I don't suggest, okay, you can go ahead and create this community edition and use that community edition. But in our course, I'm going to teach I'm going to teach using the licensed version. Okay, so V3 is all about setting up Azure account and understanding cloud services. In cloud services and deploying services required for our course. And this is what we are going to do in week 3. Week 4, introduction to Spark. Our hero enters. Introduction to Spark. Okay, I would say 4, 5, 6, and 7. We will talk about Spark, and then we'll talk about RDD concepts. We'll talk about data frame concepts. data frame concepts. Okay, and then we will talk about the data ingestion tools, which is data factory. Okay, and then we'll talk about the different optimization techniques. And then I'm gonna walk you through the uh, Python way of doing things, PySpark. Okay, and then I'm gonna walk you through uh, different concepts of Spark SQL. Okay, like how you gonna optimize your Databricks tables, like partitioning, bucketing, and then file formats. There are a lot of things in pipeline for us to learn. So I'm gonna spend those 4 weeks to teach you Spark. Okay, and then I'm gonna talk about the Databricks workflows. Okay, I'm gonna walk you through deploying your jobs, deploying your Databricks jobs, deploying Databricks jobs. I'm gonna show you passing different parameters while calling a job, so on and so forth. A lot of interesting stuff coming in there. And week 8, I will be utilizing week 8. I'm 101% sure 4, 5, 6, 7 weeks wouldn't be sufficient. We will be jumping on to 8th week as well to cover a couple of topics here and there. Okay, so this is a rough plan. Week 8, we will be utilizing maybe a couple of sessions or 3 sessions to cover up the delayed sessions, delayed topics, and the rest of the sessions would be utilized to walk you through the projects I have worked on, real-time projects, so that by that time you would get good understanding on all these tools as an individual tools. Okay, maybe you would get to understand what Spark SQL is capable of, and what Data Factory is capable of, and what Azure is capable of. Now, I will be explaining the projects by connecting all these dots, how you can create an end-to-end pipeline. Okay, so I'll be utilizing those 2-3 hours to walk you through the entire pipelines, what I have worked on. Okay. So this is what I wanted to discuss today, guys. And I know some of you have joined today, are not part of my demo yesterday, and a few new folks would be joining tomorrow as well. But we will move on to our course from starting tomorrow. So I will be walking you through the big data, and then we will start core Python. Okay, and in the interest of our license, I will not be teaching Python on Databricks, guys. I'll be teaching Python using collaborative notebook, which would look pretty similar to our Databricks environment. So I'm gonna teach this core Python on Google Colab. Okay, so which would exactly looks like our Databricks, just to save some cost. Okay, so let me spend next 5 minutes in taking up your questions. If you have any, please use chat window to post your questions. Please use chat window to post your questions. And for folks who joined late, please introduce yourself, guys, in the chat window. I just want to know your experience, number of years of experience, and what technology you are currently working on. That would give me some idea on where to start this course. I mean, I have a standard template though, but just want to hear from you. Who joined late? Yeah, hi Nivas. Okay, good. Years of experience on dynamic AX. Okay. Cool then. I'm pretty excited to start this batch. I hope the same is the case with you as well. Let's see tomorrow, same time. Okay. I know some of the folks were, not able to join today as this is a Sunday evening. That's okay. So tomorrow we will start the session at the same time, and we'll we'll continue there. Okay. Cool then. Can't wait to see you tomorrow, guys. Start my new batch. Bye bye. Have a great day, and good night for the folks who are joining from US.